Okay, so today we're going to talk about calculating doses for injectable medications. I'm going to give you a little bit of overview on this first before we start getting into the calculations. But injectable medications are referred to as injections and infusions. An injection would be something similar to administering a medication in a syringe, such as like a vaccine, which you guys have all gotten. So like injecting it intramuscularly, or an infusion is usually injection added to a large volume of fluid like an IV bag and then administered into the bloodstream over a period of time. Now, both of these are referred to as parenteral dosing, and parenteral means injection into the body. But the one thing to remember when it's a parenteral dose and we're injecting directly into the body, it must be sterile. When we compound it or mix it or make it or prepare it, it has to be made in a sterile environment, and the medication must be in sterile condition because we don't want to inject anything of bacteria based into the body. So that's really important. And then a base solution is a sterile solution compatible with human blood. It's usually a vehicle for the medication, and it's usually used in an infusion. So like an example would be, I listed them here, like 0.9%, which is normal saline, or D5W, which is dextrose 5% in water. That's usually what we put different medications into to infuse into the bloodstream in the body. Now, how do we get these in there? Really, some type of syringe, obviously, and understanding the parts of the syringe is important. So you need to know that a syringe has a plunger, which is located here. You have the barrel, which is here, the hub, which is where you attach the needle, and then the needle. So the parts of the needle is the hub, and then the sheath, and then the end is the bevel, and then the circle opening is called the lumen. How big around is that? So when we are looking at syringes, they come in a lot of different sizes, and I've listed some here, like 1 mil, 3 mil, 5, 10, 20, 50. But it's really important to select the syringe that is suitable for the amount of medication being delivered. So for example, if you're going to deliver a 2.5 mils of medication, you're going to want to select a 3 mil syringe, not like a 10 mil, because you're going to get much more accurate measurement on the medication when you select a syringe that's closest to the volume you need. So if I need 8 milliliters, I'm going to use a 10 mil, not a 20. So if that makes sense, you want to make sure you select a syringe that is, suitable for the medication that you're drawing up. Okay? So the route of admission for parenteral doses, there's three main ones. Subcutaneous injection, which is also abbreviated as SC or SQ, is in the fat layer of the tissue. Usually we think of insulin as a common subcutaneous injection, but it's more in fat. And then intramuscular injection is administered into muscle tissue, typically a longer needle. It's a water-soluble medication that absorbs pretty rapidly. And we think of vaccines, a lot of hormone injections, intramuscular antibiotic injections, things like that. And then intravenous injections, which are administered directly into the bloodstream. Usually it's an IV push, which is a bolus medication that they push directly into an IV catheter that the patient already has in their arm, or an IV infusion, which is a large volume being delivered over a period of time. So we'll inject the medication into a solution bag and then use that to infuse. Here, I'll show you what I kind of mean by that. So how to calculate injectables. This is an IV piggyback. So we'll calculate, let's say we're going to give them furosemide. We're going to inject so much into this IV piggyback, and we're going to hang it for the patient for 20 minutes, and it's going to infuse over 20 minutes. That's what that means by that. So the order is typically written in dose amounts in milligrams when we're calculating injectable medications. So we usually want to figure out how many milliliters we need to draw up into the syringe. That's usually what we calculate, because the physician will tell us, I want 2 milligrams, and we'll look at our stock solution, and it might be 5 milligrams per milliliter. So I need to know how much am I going to draw out of that stock solution, what volume to get to 2 milligrams. So that's usually what we're calculating here. So I'm going to show you here on the screen, and then I'm going to go down to the camera and I'm going to do a couple problems for you guys. So how many milliliters of medication shown in the label below would be prepared to provide a 12.5 milligram to the patient? Well, here's our label right here. And our medication we have on stock is 5 milligrams per milliliter. And we need 12.5 for a patient, but we have a 5 milligram per 1 milliliter. So looking at that right now, I'm going to ask you, are we going to need to have more than 1 milliliter or less than 1 milliliter for this patient drawing up into a syringe? Yes, we're going to have more, because if there's only 5 milligrams per 1 milliliter, we need 12 milligrams. We're going to more than double that, right? 2 milliliters would be 10 milligrams. So, we're going to more than double that. So to calculate it, you can set it up as a ratio proportion, which I did here. 5 milligrams over 1 milliliter is set equal to 12 milligrams over X milliliters, because that's what we're trying to figure out. And your solution is you're multiplying your bat and dividing by your ball, which is cross-multiplying and dividing. So 1 times 12.5 is 12.5 divided by 5 is 2.5 milliliters, which makes 100 make sense, right? And the dimensional analysis, you're going to start with what our physician ordered, which is 12.5. And we want to put the milligrams on the bottom so we can cross those off. Cross this off and cross this off. And then you're going to divide that and you're going to get the same answer. So you can do either one. Remember, I said I'm not going to make you do ratio, proportion, or dimensional analysis, but these are the two ways you can do it. And you can choose whichever way works best for you. So here's another problem. And I can go down. I'm going to go ahead and go to the camera, and we're going to do a couple of these problems together. Okay, so I'm going to see if I can draw right on this screen. We'll see how this goes. So how many milliliters of medication shown in the below label, it should say, should be prepared to provide, here's part of our question, 8 milligrams of ondansetron to a patient. This here is our order right here, okay? So we have 4 milligrams per 2 milliliter of ondansetron in our vial in the pharmacy. This is what's found in the pharmacy. And this here is what we want. That's what our patient, our doctor wants. So ratio proportion is set up here. We have 4 milligrams over 2 milliliters. Set that equal to 8 milligrams to X milliliters, because we don't know what that is. So our solution is, if we set that up, 4 over 2, and set that equal to X, because we don't know that, over 8, right? We're going to cross multiply here, and we're going to divide here, okay? So 8 times 2 equals 16, and then divide by 4, it gives us 4 milliliters, okay? Dimensional analysis is the same, except we're going to start with this number here, with the doctor gave us. So we're going to put 8 mgs and set that over. We want the 4 mgs on the bottom, and we want the 2 milliliters on top, and we're going to equal that. So we can cross those off, and we're left with milliliters, right? So we have milliliters left. And then you're going to multiply 8 times 2 is 16 divided by 4, and you're going to get 4 milliliters. Excuse me. So that's how you're going to calculate that. We can continue on and look at a few other ones. Let's go ahead and take a look at this one here. So how many milliliters of medication shown in the label below to prepare a 10 milligram of adenosine? Well, here's our label. This is what we have in the pharmacy. We have adenosine. It's 12 milligrams per 4 milliliters. And our physician wants 10 milligrams. So I'm going to set up this as a ratio proportion. I'm going to do 12 mgs over 4 mLs, milliliters. We'll set that equal to our proportion, which we don't know what this is. This is our milliliters. That's X. So we want to solve for X. And we have 10. Oops. Let me erase that. Oh, it erased the whole thing. Let's try that again. So we want 12 mg's over 4 milliliters. And we're going to set that equal to 10 milligrams over X milliliters. Okay, so we're going to do the cross multiplying and dividing. So if you do that, if you take 4 times 10 is 40 divided by 12, our answer ends up being 3.34 milliliters. We're going to round that. Ends up being 3.333. So, but we're going to round that off. Okay? So, and you can do it as dimensional analysis if you would like as well. So that's how you calculate dosing. But what if we calculate the quantity of medication? What if, for example, sometimes a pharmacy technician is going, they will have to, there will be situations in which they have to perform the opposite calculation and determine the quantity of the medication and is given the volume. It really doesn't change. The problem is exactly the same. Here's an example. How many milligrams of progesterone in 2 milliliters of stock solution that contains 5 milligrams per milliliter? So it's saying here, our stock solution, we have 2 milliliters of stock solution. And in that stock solution, there's 50 milligrams per 1 milliliter. So we have 50 milligrams per 1 milliliter, and how much is in 2 milliliters of that? So you're going to do your 50 times 2 divided by, which ends up being 100 divided by 1, so it's going to be 100 milligrams is your answer, which makes sense. So it's just you're figuring out milligrams instead of milliliters. So just really when you're doing that, pay attention to where your X is. What are you solving for X, and what are you looking for in your question? And the question says, how many milligrams? So really pay attention to what it's saying. And whatever it says here, make sure you make that your X in your problem. And I think that will help you get the correct answer. Let's go ahead and look at the next problem here, and we'll do this one together. It's a similar. How many milligrams, so we're figuring out milligrams, of carboplatin, which I'm not familiar with that medication, in 30 milliliters of a solution, and this is our label. So we're trying to figure out in 30 milliliters how much is in that, how many milligrams are in that. So we want to set X to milligrams, right? Because that's what we're trying to calculate. And we're going to put that over what we have, that's 30 milliliters, right? And that's equal. And here is our stock solution. So we have we're going to set that equal to 450 milligrams over 45 milliliters. And so you're going to do your math. And so we're going to cross multiply and divide. So 450 times 30 equals 13500, and then we're going to divide that by 45. And when we divide that by 45, we get 300 milligrams. And that's your answer right there. Okay? So I'm going to stop right there. I'm going to go ahead and do the rest of this chapter in another video. So that's it for this lecture. Thank you.